start recording now. Okay, I'm recording it now.
Yeah, thanks a lot.
And I will share it. I will share it with you. So what we're going to do is to calculate the distance each player covered at each instant. So what we're going to do is use the Pythagoras theorem. For English computers or English language computers will be square root. Okay, oops, will be square root, something like that. But here I'm using the Portuguese version, so I have to use this one. Is raiz quadrada. It's the same. Okay. And what I'm going to do now is I'm going to select first the x data, x in the moment 2. Okay, x in the moment 2. Minus x in the moment 1. Okay, and I'm going to square this number, plus, and then do the same for the y in the moment 2 minus y in the moment 1, and I'm going to square it, and I'm going to close this parenthesis. Okay, so this is the formula. The only thing that you need to change is the square root, and here we have this information is in meters. Okay, the unit is meters, so this will be in meters as well. We have around 3 centimeters of displacement between these points. So what I'm going to do is to run this information throughout all of the data sheet, okay, for this player up until the column, the line, the last line. Okay, and here we are going to have, let me just move this a bit. Here we're going to have all of the displacement. This is what the GPS software does. Okay, but we are doing it manually. But this is what the GPS software does. And here we have the oops, sorry, just to tidy it up a little bit, my screen. Okay, and here we have all of the displacements at each given moment that this player, in this case player 2, did throughout this 6 minutes of match. And if we sum it, and you have it here on the bottom, we have the sum of the displacement. You can see we have 675 meters approximately for this particular player. Okay, we can pass this to the right. Okay, and this column won't be of any use because it's using data from player 2 and from player 3. We can delete it. Okay, the same here, the same here, and this one is the last one from player 5. Okay, so we can delete all of this, and here we have the total displacement for player 2, for player 3, player 4, and player 5. Okay, player 5 did the most, was the player who performed the most meters of displacement, almost 700 meters during this 6 minutes. Okay, everyone on board? And but till now it's easy. Okay, it's easy. So in this data set, it's very it's very easy to do it because we have the data collection frequency is of 10 hertz. So we have 1 point at each 1/10 of a second. Okay, so this is the displacement. How can we transform? I'm going to place here this placement. Oops. Distance. Okay, distance player 1. How can we calculate the speed of player 1?
Divide it by time.
Yeah, of course, it's always good to have an engineer on the on the room. Thank you. It's exactly that. Okay, so what we're going to do is divide this displacement by the time, and the time is constant. Okay, it's 1/10 of a second, so you can use 1/10 of a second, and it's only a factor of 10, so it will be almost the same number, but it's higher by a factor of 10. And if you want to plot it, for instance, you'll have here the intensity of displacement throughout the session, okay, of this player in particular. So you can see the higher speed that he got was around 7 meters per second, a little bit less, okay. And here we have the speed of displacement, and we can do exactly the same for each player, and we will have the speed for all of them. Okay, so I'm showing you for team 1, then you can do team 2 on your own, if that's okay with you. But lastly, I'm going just to show you how can we extract all of this information into a simple table. Okay, so first, now we have the displacement, and now we want to, or the speed of displacement. Now we want, for instance, to calculate how many meters of displacement did each player covered at any intensity, and for that we need to determine the thresholds. Okay, so usually, let me just check here the last ones that we used. Probably easier like this. Let me check. Okay, these were the thresholds that we used. 0, 7.1 kilometers per hour, or around 7.2. 2 to 14.4, 14.4 to 19.8. So I think that we did was between 0 and 2 meters per second, 2 and 4 meters per second, I think. 4 versus 3.6. No, it was less, maybe 3. 3.5. Oops. No, it was 4. Okay. It was 4. 0 and 2, 2 and 4, and then I think 5.5. Yeah, that was it. 5.5 meters per second. So between 0 and 2, between 2 and 4, easier like this. Oops. 2 to 4, 4 to 5.5, and greater than 5.5. So these were the speed thresholds that we used, and we are going to use the same for this calculation. Okay, so the formula that we are going to use will be sum if or sum ifs. Okay, this one. Okay, or this one or this one. For the first, we can use this one, the sum if, but on the second we are going to use the sum ifs. So we are going to use sum ifs for every one of them. Okay, I'm going to use soma sis. Okay, so we are going to write this formula, and Excel will be asking us for the interval that we are going to sum, and we are going to sum the distance. Okay, and then it will ask us for the interval for the criteria. Okay, the criteria that we want to have is the speed. Okay, and then it will ask us for the first criteria. Well, the first criteria is very simple. It needs to be higher or equal than 0, okay, then it will ask us for the second criteria. The interval is exactly the same, speed. Oops. And then it will ask us for the second criteria, and we will say it that it needs to be less than 2. Okay. Yeah, I'm always wrong with this. And I think I need to put, oh, let me just check. I'm not really accustomed to use Excel for these calculations, and I always struggle with the way that they want to present the formulas. I think maybe like this. Yeah. Okay, this is it. Now I only need to check for the equal. No. It's, I think, the opposite. Okay, this is it. Sorry for that. So you need to put some commas for the condition. Okay. So what we are calculating here is the distance that the player covered when his speed of displacement was equal and or greater than 0, but less than 2 meters per second. Okay. So what Excel is doing is selecting all of the cases of this column where the condition is met, okay, when it's higher than 0 and less than 2, for instance here, and it's summing up the distance for this player, okay? And we need to do the same, so now it's only a matter of copying the formula, but changing the conditions. So now we have 2 to 4, and we have 4 to 5.5, and lastly we have 5.5. If you want, you can put like something like 20. No one is going to reach 20. Okay. So now we have this displacement at each threshold, and if we select this, the sum of each category of displacement needs to be exactly the same as the sum of the whole match. Okay, so you can see here 674.9, and if we sum this up, 674.9, it's exactly the same. Okay, so basically this is what we do with every variable, with every type of indicator. The only thing that we change is the data that we are selecting. Okay, in this case we were selecting the data of the whole match, but it would be easy, very easy, for instance, to do the same thing for this player when this player was dribbling. Okay, I'm going to show you here. This is the total distance per speed. Okay, this is meters per second. But if I want to, let's say, quantify the distance that this player in particular covered when he had the ball, okay, so distance per speed with the ball, what I simply need to do is to create another rule. Okay, I'm going to copy this formula, and I'm going to create another rule, a new rule, okay, a new criteria which will be his team, okay? And this player is from team 1, so team 1. So the criteria will be 1. And the second rule, that will be his player, okay? This player needs to be, because we are talking about player 2, okay? This is player 2. This needs to be 2, okay? I'm going to close it. And we have here the amount. Oops, sorry. This is not correct. Okay, this is it. This is the amount of distance that this player covered at this intensity with the ball. Okay, 11 meters, 0.7. Okay, is everyone following? Yeah?
Yes.
Okay, it's very simple. We usually tend to look at GPS data as some sort of black box but it's very simple. Okay, but you can see here just some potential of having this information. This information that we have here, it's exactly the same that I showed you here before. Oops, sorry, here. Okay, it's the same information as here, but it's arranged in a way that it's showing the data that where no player had the ball. Okay, in this information, this gap here, no player had the ball. So it's the same information that we have here, but stretched out throughout the whole situation. Okay, it's exactly the same. So if you want, you can do exactly the same for this here, adding this last bit of conditions. Oops, sorry, this last bit of conditions. Okay, 16 meters at this speed. Oops. This, oops, maybe I missed something. Yep. Okay, 1 meter at this intensity. And here we are going to have okay, he didn't do any displacement with the ball at speeds greater than 5.5. So, and if you sum this up, you will have the total distance, 30 meters, that this player spent with the ball. Okay. If you want to check the time, for instance, that the player spent with the ball, then you can use the other function. Okay, you can use, for instance, the count if, and that function will count the number of times that the player two in team 1 had the ball, and since the time in this situation is constant, you can factor it and calculate the time that the player spent with the ball in his possession. Okay, so a lot of opportunities, a lot of things that you can do. I'm just going to show you another one that we can do in Excel as well. Okay, before passing the ball into your side and creating some groups for you to work. Okay, is everyone following?
Yes.
So
Yes.
I need to know just the first formula because I didn't note it.
okay, which formula?
The first one from that you calculate the displacement and the speed.
Okay, so what we did was we asked Excel to sum
No, not that one. Sorry, the really first one that you
Oh,
use
okay, this one. For
as a
calculate the speed,
yes. Ah, okay. Yeah.
we have the distance. Okay, we are just going to divide this is the, well, in the very physics terms, the delta, the delta of the displacement. Okay, the
Yes,
variation of the
that is
displacement, the distance that they covered, and divide it by the difference in time. Okay, the delta time. So the
that
delta
was
time.
for the distance. The distance is noted.
Okay, the distance is the Pythagoras theorem. So the square root of position, the x of the position 2 minus the x of position 1 squared, plus the same for the y position of player, in this case player 2, and player oops, this is not
Okay.
player 2, this is player 2 and player 2, sorry.
No, that's clear. That's clear.
Okay. Okay, so last thing that I'm going to show you. How can we calculate the distance between players, for instance? Okay, it's
again Pythagoras theorem.
Yeah, again. Thank you. Thank you. It's exactly the same. But here we are considering time 1 and time 2. Okay, so we are considering this information and this information. And if we want to do the same for player 2 and player 3, we will be using this information and this information here. Okay, this data and this data. But it's exactly the same. So if we want to calculate the distance, for instance, between player 1 and player 2, we are going to use the same formula that we did before. Okay, so x of player 2 minus x of player 3, in this case, squared. Okay, and the same for y minus y of player 3 squared, and here we will have the distance, the time series of the distance between these two players. Okay, this is it. Okay, if you want to plot it, so here we already have the this is first one indicator, one tactical indicator that you can use, the distance between players. We can calculate the distance between any given object that's within this situation. The referential, one thing that I forgot to tell you, the referential of this situation is a situation of 40 meters of length by 30 meters of width. Okay, so the x referential goes from minus 20 to 20 meters, and the y referential goes from minus 15 to 15 meters in the lateral displacement of the players, in the lateral direction of play. Okay, the 0, 0, the reference point, or the starting point of the referential, is exactly in the middle of the pitch. Okay, so this is one of the things that we tend to use constant, in a constant manner. This point here, okay, this point here will be the 0, 0 of the pitch. Okay, just for your consideration, if you want to make any calculations. So in the same manner, the midpoint of the goal on this end will be minus 20, 0, and here will be 20, 0. Okay, if you want to calculate anything that is related to any field positioning, the half line is at the 0 in the x axis. Last one, and just for another quick example. If we want to calculate, for instance, the length and the width of this team, considering only the field players, how could we do it? Okay, so I'm going to show you. So what we need to do is calculate the max value and the minimum value for the, in this case, if we want the length will be the X positioning, okay, the X data. And if we want the width, then we need to consider the Y positioning. So we're going to use, oops, sorry. We're going to use the max, oops, in this case is, I think, this one. Let me just check. Mayor, yeah, that's it. And we are going to use only the X information. I think it's something like this. Nope. Like this. Yeah. Okay, I'm not sure if this will work. This is, I'm not, as I told you, I'm not exactly accustomed to work with Excel, but I've done it in the past. How can you select only only one column at a time? I'm not sure this will work. Nope. We need to pass. Okay, let's do it like this. This will be this one. This will be this one. This one. And this will be this one. Okay. So now we have all of the X together. Just one. Okay, and now what we're going to do is to calculate the maximum of this matrix. Okay, and we want the first one. Okay, so this is the higher number for this matrix. Okay, in the X, so the higher number in terms of the length of the team. And now we're going to calculate the minimum, which is menor, this one. Again, for the same matrix, and this is only because we want the greater number. Okay, and if we take the max minus the minimum, then we will have the team length. Okay, in this case this is the team length throughout the whole situation. So you can see maybe when they present greater numbers, they are attacking more dispersed. They are trying to accelerating their attack, probably. I don't know. When they are have a more closer formation, probably they are defending. Okay. So just to show you a couple of examples of things that we can do from our database, and the okay, my suggestion now is to, well, use the data to create any sort of performance indicator that you want. Okay, try to explore the data. So I'm going to divide you in groups of 3, create some additional groups here. Okay, and you can try to discuss within the group and try to explore the data. And I will go from room to room and try to help you with some trouble that you have. Okay. So I will create the rooms. I think that I need to stop the data sharing first. I'm going to stop the recording.